Hey folks, hello. Check test, hello. Hi, welcome to DC404. So this is the March meeting, and our topic today is Docker, and we're trying this time to stream it out on YouTube Live. I'm not sure if we're a little bit bandwidth challenged on that. That's what I've been trying to get fixed, but I think we could go ahead and start if you're ready to start. Okay. All right. Yeah, you can sit it on the corner right there. And we have a wireless mic. If we want to send this around, if you have questions, if we don't send this around, then it doesn't go out on the stream and it doesn't get recorded. So.
Can I put it right here? Actually, I think that this might be. Can I use it right here on this corner? Actually, I can move this here.
Well, I want to. What did you want?
Do you think I can move this table? Just put it right here.
Yeah.
Will that work for the HDMI cable?
It will. I'm going to try to have to hit it with a projector. I'll move it around. We'll figure it out.
Okay.
Go ahead.
It's going to be very interactive because my slides. Or they're the best thing ever. All right.
Here's the HDMI.
Awesome. Thanks.
There it goes.
Yes. There we go. Okay. Cool. Well, I can get started now, then.
Let me hit record.
Okay. We're good? Okay, cool. Hey, what's going on, everybody? Thank you all for having me. My name is Grayson. Been in the Atlanta area for a while. Seen a lot of familiar faces here. So, I was talking to Keith the other day, and I was not planning on giving a presentation until like Thursday, but I have a lot of other things on my plate currently. So I was like, I really want to talk about Docker, but I don't really have the bandwidth to make slides. But then I was like, well, then it would just be awkward to not have slides. So I made slides. But as you can see, they're just going to kind of direct conversation. And I've tried to make up for the lack of depth in the slides with other elements. So just a fair warning. Yep. All right. So this is a Docker presentation. We're talking about Docker here. Who here has used Docker before? Okay, so we got it. Who here has heard about Docker before? Okay, so lots of people. This technology is awesome. It's, in my opinion, revolutionary. There is going to be it's not immediately obvious why, and that's kind of one of the things that I want to address here, because if you don't use it properly, it doesn't really make sense. It doesn't really basically Docker has this whole suite of tools that everything put together can literally make it so that your DevOps, you handle it with one person out of the box entirely. It's incredible how quickly you can deploy things, how quickly you can get them working across various environments, things of that nature. But the way that all of these different pieces kind of interplay with one another is not immediately obvious. So that's most of what we're going to be talking about. So, who am I? I'm Chris Grayson. We already went over this. What does this talk about? We're going to talk about Docker. More specifically, what are we going to talk about? We got these 5 things. So we have Docker, Docker Machine, Docker Swarm, Docker Compose, and Docker Registry. I don't know how all of these things have kind of been congealed into one company. I will say that depending on which of these you're using, it's written in a different language. There's some very there's a lot of terminology that does not mean the same thing when used with different tools. So it hasn't really all been put into one coherent package yet, but there's a lot of effort trying to make that happen. But so going through these real quick, Docker is what we're going to talk about first. So Docker is the actual daemon that you're working with. It's what enables you to deploy things. You can talk to it remotely, yada, yada, yada. Docker Machine allows you to deploy Docker daemons very easily on remote hosts, on local hosts. It's basically kind of very painless, let's get Docker up and running somewhere else. Docker Swarm is this really cool technology that enables you to take multiple physical hosts and virtualize them into one logical host. So as far as your code is concerned, your code might be running on like 40 different machines, but your code doesn't have to know about that. It just thinks that it's running on one machine with 80 cores. And the kind of intricate details of, well, actually, I've got one machine up in AWS and one in Google Compute Engine and one on DigitalOcean and one on Linode, but I've strapped them all together with Docker Swarm. Your code doesn't have to care about that whatsoever. Docker Compose is a way that you can spin up an end-tier application in less than 15 seconds. It's really impressive. And then lastly, Docker Registry is kind of the version control system for Docker. So the way that you have GitHub for Git, you have, what was it, Google Code. Is that still a thing? I don't even know if that's still, no, it's not still a thing. So you have places where you put your source code. Well, Docker Registry is the same, but it's for the images you're building with Docker. So let's start talking about the Docker daemon. So the Docker daemon, I guess this is probably a good time for me to actually switch over to, let me show some actual Docker stuff running. So can everybody see, can everybody see that pretty well? Everybody can see that? So Docker is a service. It runs on port 2376 TCP. Normally, when we talk about Swarm, it's actually running on port 3376. So again, this is something that you can connect to remotely. It uses mutual TLS authentication, and also it builds an encrypted channel from that as well. So when you talk to it, so for those of us that are, in the pen testing, it's like, oh, you have a service where you can deploy things that you're having on the open internet. I don't like the idea of that to begin with, but it's pretty strong, mutually assured. TLS, you have to have the private keys and certificates to even connect, things of that nature. So you're talking to a daemon, and when you start working with Docker, that might not be immediately obvious. It definitely wasn't for me. I thought it was just like a command line interface for a program that I had running locally, and that I just didn't understand that, but you're actually talking to an HTTP API. So for instance, let's see so let's see, here's the actual Docker command. It's got a lot of stuff in here. I'm not really going to go over the details of it, but Docker does virtualization at the process level. So you're not virtualizing operating systems, which everybody that I've spoken to, one of the big breakthroughs to actually start understanding Docker is wait a second, it's not the virtualization that I've seen before. Because when you think virtualization, it's oh, well, I have my own operating system, and it's physically separated from all these other things, and you have to do OS escapes to actually get from one place to another. That is not what's happening here. It's all in the same OS. It's using Linux kernel security modules to do very strong isolation of the process and all this jazz. So basically, what happens is you first build something called a Docker image. So let me go to where I have some of those. So this is something called a Dockerfile. So basically, this is kind of the recipe for how you build an image. For this one in particular, this is building so a friend of mine took Nginx source code and then took all of this, I forget what it's actually, page speed. So there's a bunch of like third-party modules that you can compile into Nginx that do crazy amounts of optimization and stuff just out of the gates. You don't have to touch it, like it does it all itself. I want to say it's even HTTP 2.0 compatible, so automatic upgrade without you having to write any additional code, things of that nature. So he went ahead and wrote a Dockerfile for how you actually install it. So in his Dockerfile, actually, I guess I do have that. Let's see. So this was made by my friend Joe, and he basically has this whole script where you see run apt-get update, run wget, all this stuff. It's doing it's actually compiling from source. It's installing these other things. It's running this cleanup. It's making all the directories. So one thing with Docker, with all of your images, you have to have a foregrounded process in whatever your image is. So for instance, Nginx usually runs in the background. So again, you have to here configure Nginx to run in the foreground. That's one of the weird caveats with Docker, is that your image has to have something in the foreground, because once Docker sees that process die, it gets rid of all of the stuff that it has set up for it. So he wrote this Dockerfile. And this is awesome because I can take this Dockerfile and I can run it locally and it will build this image pretty much guaranteed. Why is that? So we go up here to the top and you'll see this from Debian latest. And so that basically says, go ahead and it tells the Docker daemon, go ahead and find the image with this tag. And so this actually reaches out to Docker Hub and says, hey, give me the latest image of Debian that you have. It pulls it down, and now that is what the rest of these commands are being run on. So basically it spins up this like little mini Debian instance and then runs all of these commands, which again, install Nginx directly onto it. So bare bones and Debian install now has Nginx on top of it. And then it saves it out with a different name, okay? So what I wanted to do is I also wanted to add some additional functionality to that same thing. I was like, I really like having that upgraded version of Nginx, but I also need stuff on top of it. Well, what's really cool about that is now I can just say, hey, from the image that he built, go ahead and run these on top of it. So you can take images and you just start layering things on top of them. So for instance, if you're a development shop, you probably have a bunch of dependencies that your code relies on. Well, for me, I have a base image which has all of those dependencies installed. And then I have another Dockerfile which says, hey, take that image and then put this code on top of it. And it's that easy. So this, in this case, is installing something called Docker Gen, which is a utility. I'll come back to this when I start talking about Docker Swarm. But basically, this Nginx, as I scale up and scale down the amount of workers in this cloud of processes that I have, Nginx transparently, it's like, oh, this new worker came up. Let's go ahead and reverse proxy to that as well. So it's doing load balancing on the fly, figuring out who it needs to be, where it needs to be sending traffic, and all of that jazz. Oh, God, Microsoft, get out of here. So these are Docker files. Now, so how exactly do you? Man, it must be a huge pain in the ass to build something then, right? No, you just do like Docker build. Let's see. I don't want to do that here. That would really mess up some things. So this will be, yeah. So basically, you do Docker build, and then you give it a tag, and this is just the tag that I'm using to identify. This is the image that actually has all of the code and stuff installed into it, and you just hit go, and it's now running through that Docker file, running all of these commands. Ooh, and you know what? I'm not going to do that here. That's a bad idea. So it's that easy, basically, and especially if you have something that takes a long time to install, like all of your dependencies. You have to compile stuff from source. You have to update the kernel. You have to do all these different things. You do that once, you package it up into this nice little image, and then the next time you need to install something on top of it, it's like, well, I just write another Docker file, and then I have that put anything on top of it that I need. And so you're now separating out concerns of the effort you're placing where, because it's basically like, well, so long as the base image has all of the dependencies installed, then your build time has now been reduced by like a factor. So that's pretty awesome. What happens once you actually build an image? Oh man, let's see. So I'm giving a talk on some things about Docker, which are some of the downsides of using Docker, which I can't give away any information here about. But so let's see, I'm currently connected to that. That'll work. Okay, Docker. So this is now querying again via the Docker API. It's talking to an API and saying, hey, what are the images that you currently have that you know about? And here I have, so for my end tier application, I have code, I have Nginx, I have a Redis instance, and a RabbitMQ instance. So it knows about all of those. So now let's see how easy it is. So I've got all of this stuff already packaged up. I've done the legwork. I got the Dockerfile. I built the image. How difficult then is it to run any one of these things? Let's see. I'll do. Unfortunately, the internet here is rather slow, so this might take a second. This is normally much, much faster. But so that's it. Now, there we go. I now have, this is remote, by the way. This isn't on my machine. This is up in the Amazon cloud. I now just said, hey, go run this Redis instance that's entirely already pre-configured, ready to go. And it's, there you go. It's right there. Done. So, let's see. So in summary, basically what you do, kind of a difference from how standard shops operate without Docker right now. Instead of having like your continuous integration environment, just like pulling from Git and then like throwing into an image, building an ISO, deploying that out to a VM, taking down the VMs that used to have the old code, stuff of that nature. It's literally, you have the code locally, and if it runs locally, I guess this is kind of one of the biggest selling points that I've missed thus far. If it runs locally, it runs elsewhere. I don't care what your base operating system is, whether it's Debian based, whether it's, they even have it for Windows now, whether it's on OS X. I don't care. If it runs here, it runs there, guaranteed. Which is for anybody who is in DevOps or has had to work in a place where, that's a huge, huge time sink. You have dedicated personnel for taking care of that problem in a lot of cases. So let's see, what else have I missed about this? So you can build images. You basically build your Dockerfile, you install your dependencies, you now have a base image, and then the Dockerfile for actually taking the code and placing it on the image. All it is it's one line that says, add this code to that location, and when you spin up, change directory here, and then run this. And then every time you just say Docker run that image, that's what happens out of the box, ready to go, no matter where you deploy it. So it's immediately pretty impressive for your ability to just kind of say, hey, you know what? You have some new developer that's come onto your team. It's like, you know what? Instead of taking this first week trying to get this application running on your machine, install Docker. We'll give you access to this registry. And then you just pull the image and hit go, guaranteed to run. So that's great. And so I guess this would be a good time. Well, I have other slides for it, so we'll wait for that. Okay, so that's Docker.
Well, still in the Docker part, can you explain process virtualization versus OS virtualization?
So what part of it do you think? Because the idea, I mean, when you talk about operating system level virtualization, you have one physical machine, and that machine has some sort of hypervisor, and you're now spinning up additional machines on top of it, so the actual hardware is being virtualized in a lot of cases, right? So the operating system that is in a VM sees like, oh yeah, I've got all this cool hardware, but it's not actually hardware, it's software. Some of it's like passed through to the hardware, but that's the level of isolation that you have. And in that case, when you're talking, so what do you actually virtualize? What is the image size? At that point, you are like, well, let's say that I have this Ubuntu image that's like 4 gigabytes, and also it's the ISO. So first I have to install it, and then I have to install my dependencies. Then I got to bring my code in there, and then maybe I'll image it, something of that nature. You package it all up. when you go to spin it up, it takes the whole like boot up lifecycle for that image. So instead of just a process like starting, you have to boot up a whole operating system. So looking at this, and I say, yeah, it's from Debian latest, right? So that might be kind of confusing because, yes, obviously that is also another Linux operating system. But in Linux, everything is a file, right? So what actually happens with Docker is it packages up all of the files that you need into this tarball. And then when you deploy or when you start a Docker process, it actually takes that whole tarball, puts it somewhere, and then starts a process that is very strongly trooted into it, right? So you have a separated file system, you have very strong kind of, I guess, security separation between processes between them, and it's much, much faster because you're not actually virtualizing all of the like operating system calls, you're not virtualizing all of the hardware, you're on the hardware. You just don't have access to all the other processes, and you don't even know about them because, again, everything in Linux is a file system. So all of the things that I'm using to interact with hardware and things of that nature are being redirected to like middle tiers that are handling that in a way that is abstracting the fact that you're just in a process away from you.
So is root the deployed image a local root, or is it root on the system from which you deploy the image?
Can you ask that one more time?
Sure. So if you deploy an image, it has its own file system as far as it's concerned inside.
Yes.
Does it have its own set of users? If you're running something as root,
Everything runs as root. Yeah. So this is one of the things that security practitioners kind of latch onto immediately. Is like, oh man, by default it runs as root. They have it in the cards to make that not happen, but the users are separate from the operating system
Okay,
users.
so it's not the same root.
It's not the same root as far as I know. I'm not like a hardcore like Linux kind of file system guy, so that could be erroneous. But if you compromise a process, you have only compromised the process. You do not have access to the operating system, right? So you have to do something called a container escape at that point, which there's definitely ways to accomplish that. But you don't immediately have access to the operating system. Whereas, if you're doing the normal method of virtualization, if your virtual machine gets popped, they've got it's basically an attacker having physical presence on a box that you own. Does that answer your question?
I think so.
Okay. If not, just let me know where I can go with that. So Docker Registry, not very complicated, but very interesting for the talk that hopefully will get accepted. But this is basically where you store all your images. So you push images, pull images. The idea here is that so within a corporate environment, instead of having your own internal GitHub or your own internal Atlassian stash, I want to say. Bitbucket? Is it Atlassian Bitbucket now? Yeah, whichever. Yeah. Basically, instead of having all of these source code, I mean, you'll have them in addition to it, but you now have a centralized registry where all of the developers can pull down an image, which is guaranteed to run, and then develop against it locally. So the idea being that, let's say that you have, again, that base operating system image that has all of the dependencies installed. Well, you actually pull that down locally, and then you mount your code into it, so it's guaranteed to run in this environment, and then you still have a continuous integration system, which is building the images for production. But, again, I mean, all of your dependency worries go out the window. So Docker Registry is a centralized repository for pushing and pulling those images. So you give access to people to actually push to it, and then you have permissions for wherever the image needs to be pulled to pull from there as well.
Can I make a snapshot of somebody's image? Like you're saying, you want to pull from somebody's previous build, and you want to, yeah.
Hi, Mike Slivkak. If you wanted to continue development on something that you want to base on something that is already in development, but you want to freeze it, can you make a copy of that image and then build on your copy?
You can. Let me show you. Let me see if I can. So I don't know if you caught it, but when I was doing the build, you see how it says DataHound base and then :latest. Latest is a tag. So you can basically think of it, you have a centralized repository which you can push and pull images to, but then you also have a local version as well. And so you can pull an image down and then tag it with a different tag. And then so let's say that I have like an image called foo, And the one that I want to build on top of is the latest release. So I say, give me the foo image, the latest one, pull it down, and then I can say, you know what? Tag that as like save me. So now you have foo:/save me locally. Well, then you can just do pull foo latest again, and you'll pull that image down again, but you'll have a local copy that was snapshotted at that point in time. I'm not entirely sure if there's version control. I haven't had a need to look into that yet, but there might even be the ability to roll back to like previous iterations. From what I've seen in practice, people will push an image and then tag it as a version. The default tag is latest, so if you omit a tag, it's pushed and it's given the tag latest, and then you can tell the registry, hey, tag that as 0.0.1, stuff like that. So that's the registry. The registry is fairly not complicated, but it's one of the working components. You got to have access to it to pull images, to push images. So Docker has their own offering called Docker Hub. Okay, I guess I will get into the actual potentially negative security implications of using this stuff at the end of the talk. But I'll tell you what, if I was a malicious third party, I would really like to compromise the place that has all of the world's images, because that's where a lot of sensitive code is. And again, this stuff works out of the box. If you gain access to an image, you can get it to work elsewhere. So that's Docker Registry. Let's go on to Docker Machine.
Can you post it on registry?
Yes, you can host your own registry. That's what I do, and that's what a bunch of people do. A lot of people do that. They don't do it well though. So yeah, there's open source code out there for the registry. There's images. So literally, if I want to have, here's how complicated it was for me to get a registry up and running locally. I use Docker Machine, which I'm about to show you, and then I say Docker run registry. Up and running, done. Remotely, wherever I want, it's there, running, good to go. Because when I say Docker run registry, the Docker daemon says, oh, you're looking for that registry image. I don't have that. Hey, Docker Hub, do you know something about this like registry image? And it's like, oh yes, this is that registry image. Pulls it down, starts running it. The Dockerfile that image was built from has all of the actual settings in it that when you hit run, it's like, okay, well, I run, I'm on this port, I've got this setup, I've got this, that, and the other thing. So it just goes. It's that stupid simple. It's 2 lines to go from I don't have a machine to having a machine and having it running Docker Registry. That's how fast you can go with this sort of stuff. So, now Docker Machine. So Docker Machine is used for provisioning either physical or virtual hosts to put Docker daemons on. So it has all sorts of, basically it enables you to go from I don't have an endpoint to actually deploy images to having an endpoint up and running, daemons running, I can deploy to it, all of that jazz. So let me show you how easy it is. So I use DigitalOcean for pretty much all my stuff. I do like them quite a bit. And so if I do, oh, that was not good. Well, you know what, I'll just delete it after this, because that's definitely not something I should have shown anyways. So this is going to be, so you see a bunch of stuff up here, including my DigitalOcean access token. And so you'll see a bunch of these things say DigitalOcean, DigitalOcean, DigitalOcean. So what Docker Machine has is a bunch of different drivers, and the drivers are platform specific. So basically, there's a bunch of command line flags that you fly with Docker Machine drivers. I bet there's people on IRC that are already trying to tap that in. God. Well, it's not even the password. They'll be able to spin up machines as me. That would be kind of a pain in the ass. There. So. Yep, there it is. So this is going to go. There. Okay, so here's here's what's going to happen. I'm going to hit enter here, and I'm going to go from not having a machine to having one up and running, ready to go. So while that's running, I'll get that out of the way so the people that are watching and trying to break into my shit don't have as much time. So basically, that's going to be running in the background. But what that's doing right now is it's talking to the DigitalOcean API. It's saying, "Hey, I need you to spin up. Some things." It spins them up. It waits for SSH to be listening. Once SSH is listening in, it SSHs in. It installs the Docker daemon, and then it copies over all of the certificates that you need to then communicate with the Docker daemon, and sets it all up. And then once it's done, I will then have access to that machine remotely. And now I'm going to take a quick break to delete that access token. 1 second. If the people that I know that are in IRC are watching this, I know they're already going after it. Well, I log in and I see like 20 new images. Haha. If anybody was trying, I beat them. Wonderful.
Does it make sense to run Docker on virtualized hosts instead of just running more virtualized hosts?
Yes, without question.
No. What is the advantage that you
Okay, so who here runs applications in virtual machines? Yeah, okay. Tell me about like one of those applications. You probably have one application running in it, right? You've got one virtual machine. It serves one purpose. It's running this one application, right? Why the hell do you need a whole VM to run one app? Wouldn't it make more sense to only have a process? That's really all you're doing. You have this massive amount of overhead. You're virtualizing all of the hardware. And your goal is, I need an environment for this one process to run in. So virtualization is already being used to virtualize at the process level, but instead it's being virtualizing at the operating system level, which is enabling process level virtualization, but it's incredibly ineffective. So what Docker does instead is say, look, what you really want virtualization for is process level isolation, because the amount of overhead you're paying to do it at the virtual machine level is just not worth it. There's no justification to do it.
So how does resource management work?
Aha, so it uses all of the Linux kernel primitives for that. So you have like CPU shares. You have ways that you can say, here's how much I should give to, I want to say it's all relational as well. So you can be like, give 75% to this container and 25% to that container. The thing that concerns me most is something called the global interpreter lock in Python. Because then if you're running, if you've got a machine with 2 cores and you're running 4 Python processes on it, it's a really ineffective use of your resources. So there's ways that you can tell Docker, like when you're deploying these, hey, reserve 1 core for this process, or reserve 2 cores for that process, or reserve this much memory for that process. So that is something that you have to pay a little bit of attention to, but far less attention than you would have to have paid if you were doing operating system level virtualization. So it's still an improvement. So let's see if that worked. So it's still, okay, well I guess I can show it now because it doesn't exist anymore. Ha. So it takes a little bit, especially if with a slow network, but this you can also parallelize out. So basically with Docker machine, I can go from, hey, I don't have any infrastructure, nor do I have anything running, to having all of my infrastructure up and running with my n-tier application in less than 5 minutes.
Can you use Docker to write iOS apps or Android apps?
Can I use Docker to write iOS or Android apps? In what sense?
I mean, write an application and run it on an iPhone.
So the point being that I want to run Docker on an iPhone, or I want to use Docker while developing it for an iOS device?
Either or. I mean, how flexible is it to use it on other than a Linux operating system?
So it is exclusively on Linux, except, well, so I want to say Windows has now made Docker work on their platform as well. But so on OS X, for instance, when you install Docker, it just transparently installs headless VirtualBox and installs a Linux ISO into it, which was, again, a very confusing thing to me, because I'm thinking this Docker command line interface is just like a local binary or something, but it's actually talking via HTTP to a VM that I didn't even know I had running. So that was very shocking to me. So I don't think it really applies. I don't think that's really one of the use cases for it. This is something that, for the most part, is going to be the biggest advantage as far as tech shops are concerned is, look, if I get this running, if this developer has it running locally on their machine, it's damn near guaranteed to be running both in dev, QA, integration, user acceptance testing, and in production. So there's not this massive difference between all of these different environments, which I'm about to show with Docker Swarm. But
That was also kind of one of the goals of stuff like Baker. And I don't know about people.
it's still operating system level, though, and that is the problem.
So, can you run Docker in Docker?
You can. There's even something called DIND, D-I-N-D, Docker in Docker. And it's I don't really, from my understanding of how all these things work, if that's your architectural approach, you're probably not understanding how Docker works. But there can be, especially when you start talking about the isolation primitives that they're using. So for instance, when you run a Docker container, it's being isolated by these isolation primitives provided by the Linux kernel. But if the Docker image has access to enforce those on something else, it also has the ability to take it off of itself. So it's like, in order to have Docker within Docker, it already has more privileges than it should, and you probably shouldn't be doing that. But yes, it's very much possible. When I was first using Docker, I was like, that sounds like what I need to be doing, and then I found out afterwards, like, no, that's not it at all. So still going over here, if this was on a more stable connection, this would have been done, half as long ago. But once it comes up, we will go ahead. I can actually come over here. And that's, so I can do, this will go ahead and list all of the machines that I have access to. So we'll give it a second. Oh, and it looks like that actually just finished. Ah, wonderful. Yeah, because it timed out. No surprise there. So here's all of these endpoints that I have access to, and you'll see there's foo right there. That's the one that I just spun up. So it's up and running right now. And you'll see I have one in VirtualBox. I have a bunch on DigitalOcean. So another really big appeal of this is what I was talking about earlier. With Docker Machine, you have different drivers for all of the different hosting providers. The rest of the commands stay the same. So if I was like, you know what, really tired of DigitalOcean, it's not working for me, I need to move to AWS. I mean, for those of you that have done like code migrations or environment migrations like that, how long does that take? That's a full-time effort. That's like, okay, that's going to be this quarter's project, is migrating from this hosting provider to that hosting provider and making sure it still works. Nope. The only thing you change here are all the command line flags that are specific to that driver. I just pull out all the DigitalOcean flags and I throw in the AWS flags, and now everything is up and running on AWS. So I can literally go from one hosting provider to the next in half a day and have all my code up and running. It's, half a day is being conservative as well. So now that we're going to go back. So does anybody have any questions about Docker Machine? Sweet, that's pretty straightforward. All right, and next we have Docker Compose. So we've already talked about, we got the images, we know where we store the images, we have a way that we can say we're going to put Docker daemons all over these places. So cool, now I have a bunch of Docker daemons that I can talk to. So one of the reasons that DevOps takes so damn long is because the bigger applications that enterprises are building are just, I mean, they're massive. They have so many different moving components. They have to all be networked together. They have to be able to talk to each other. You've got databases, you've got message queues, you've got reverse proxies, web applications, you have task nodes, you have all these different things, and they all have to be on the same network and all this stuff. And getting that to work is one of the reasons that migrating from one hosting provider to another takes so much time. Well, that's where Docker Compose comes into play. Basically, Docker Compose plays on the word orchestrate. So there's the term orchestrate talks about how, we're going to this is how we're going to deploy everything. It's a way that, hey, we have this cloud provider doing all these things. We're going to orchestrate the deployment so that everything gets in the right place at the right time and it's all talking together, playing nicely with one another. So Docker Compose. Let's look at what it takes to run Docker Compose. It's very difficult. So we're going to come back here. We'll go to my local version. So this is a Docker Compose file. It is basically what you see here. I want to say it's a YAML file, but you'll see something with a colon here and then a bunch of things kind of tabbed over. And so what this is the name of an image, so RabbitMQ. It's a name of an application, so it's basically saying, hey, when you need to reference this application, just use the term RabbitMQ. I've got an image, so here's my image right there, so that's an image that I have built. And then I have CPU shares, which this is how I say, this is how many cores I need you to reserve for this particular application. Expose, this is talking about the networking stuff within Docker can be a little tricky just because of the level of virtualization, and it's kind of difficult to wrap your head around because it is a process, but that process has its own IP address. So that it kind of gets a little weird. It's a whole virtual network that is deployed when you spin things up. So you have the notion of this virtual network that these processes can talk to each other on, and you have two things you can do. You can basically say, I need this container to let the other containers talk to it on this port, right? And then you also have, I need that container's port to be mapped to the host, right? So you can potentially have an n-tier application all running locally, all talking to each other in this virtual network, but all you really want is for people from the outside to talk to Nginx. So you say, hey, take Nginx's port 443, map it to my host's port 443, and then here's all these other ports that I need you guys to be able to talk to one another on. So you'll see differences ports down here and then expose up here. I forget which one is which. You have to learn a lot of kind of very proprietary language when working with all these different technologies, but that's what those are referring to. You also get stuff like restart always, so if the process crashes for any reason, Docker will immediately spin it right back up and get it going again. You can pass environment variables, so when talking about configuration, environment variables are what Docker relies on. So when you're deploying, one of the things that you have to do to convert your application to be like Docker compliant, if you want to be using their best practices and methods for deployment, is you convert your config files to environment variable files. And you set those environment variables within that process, because again, processes have their own environment variable space. So you pass those environment variables in, your application pulls the config from the environment variables, you're good to go there. Did you have?
So if you've got like a VM or whatever, you might use something like Ansible to set up the whole VM. What is the Docker?
You would use Docker Machine to set it up.
Okay, so basically Docker Machine would basically set up all the...
You don't need anything on the base operating system other than the Docker daemon, because all of the dependencies that your code is relying on are in the image. So it's not like you have to install crazy stuff on the host. All you need, bare minimum, give me a Linux distribution up and running, throw a Docker daemon on it. I don't need anything else on it other than SSH access, which is automatically filled out with Docker Machine. So this gets rid of Chef, Puppet, Ansible, like done. We're not dealing with that stuff anymore. There are plenty of shops that still use them together, but it's just complexity for no reason, other than antiquated practices which don't die easily. So all this jazz. And so then you also pass the command, like, oh, here's the command I need you to run. End file, so this is how I'm passing all of my configuration variables. Is okay, take this file and just put everything in the environment variables within that process. And so you'll see here that I have 5 different applications defined. You'll see the first one I have is RabbitMQ. The second is Redis. The third is Nginx. The fourth is app. And the fifth is worker. Okay, so I make this Docker Compose file. I have a bunch of configuration for each of the processes that I need to be running, and that's the entirety of the Docker Compose file. So I do not have my application running locally right now. Let's change that. Oh. And I'm realizing now that I skipped over one important detail of Docker Machine. So I'm willing to bet that this comes back and says that I'm currently talking to Swarm Master. Yes. So you see active here, and you see an asterisk here. So going back to that the Docker command line interface is really just interfacing via an HTTPI to a remote Docker daemon. So in order for you to change the daemon that you're talking to, you actually set environment variables in your bash shell, which say, here's the IP address and port, here's the certificate you need to use to authenticate, and here's the certificate authority that you can verify that they are who they say they are as well. So for instance, I want to actually switch over to default, because default is my Docker daemon which is running in VirtualBox locally, because I want to deploy this locally, right? So, oh, that sounds like a real pain in the ass, having to change environment variables, gee whiz. Okay, now I'm talking to my local Docker daemon. That's it. That's it, that's all. If you can't see it down there, let's see, Docker. So it's this command env, which you pass to Docker machine, and then you give it the machine you want to be talking to. And what that actually does, you'll see here, first off, so I use fish shell, which has different syntax from bash shell, but this figures out what shell you're using and then has the correct way to set environment variables automatically spit out by it. But so what you do is Docker machine env and then the machine you want to be talking to, and here's the environment variables. So we have whether or not it should be verified, we have what the protocol is you should use, the IP address is, where the certificate is, what the machine name is, all of that stuff. So that is what happens so to actually start talking to it, you do an eval around that statement, which evaluates the results of that command, which goes ahead and sets those environment variables. And now those environment variables are what the Docker command line interface uses to actually talk to a daemon. So now my Docker command line interface is configured to talk to my local daemon. And we can see, so I'm going to invoke Docker, the command line interface, and I'm going to say, show me what containers are currently running. So one of the things that I struggled with when I was first learning this is like, man, what the hell is a container? A container is a process. That's it. A container is, I have an image, I deployed it into a process. That's a container. Show me the containers. I got none of them. None of them working right now. So basically on my local Docker daemon, I've got nothing running. So I'm in the directory where I have that compose file. Now I'm going to use Docker Compose. Tell it, hey, I want you to use networking. We'll get to that in a second. This is some crazy stuff that this works on. All right, there we go. My entire application is now running. That just spun up Nginx, Redis, RabbitMQ, web node, and a worker node, all 5 of them. Not only that, but all of their logs are coming out right here. If you've ever had to debug an entire application, have fun. Because trying to correlate disparate logs from different locations is one of the biggest time sinks that you run into when you're doing something like that. Instead, there's the logs for RabbitMQ. There's the logs for my worker node. there's the logs from my application node. There's the logs from Redis. What's really cool is you can actually, once you do a request to this, you'll actually see Nginx log something saying it received the request, and then you'll see the application node handling it, and then you'll see Nginx spit it back out. So that's a huge appeal for me personally, at least, because it's, especially when you're developing complicated applications, it's very hard to debug when something is breaking where exactly it's breaking. This takes care of that issue for you. So now it's running. It's literally, I now have a virtual network on my local machine. This is on this laptop right here. I've got 5 processes that all think that they're in their own operating systems that are all talking to each other across a virtual network. Their own IP address, yeah. So they're on a virtual network. They have access, not only that, but within the virtual network, they are ACL'd off by default. So unless you explicitly say, hey, these containers should be able to talk to each other, they can't even see them. So it's fail close. That may have changed with they got away from this thing called linking, so that may not be the case anymore, but I know it used to be, and it was definitely something that I was like, oh, that's awesome. So now that I have that running, so here's my application. This is an N-tier application right here, and it's all running locally, just like that. And it's got the database, it's got everything just kind of hooked up, ready to go. Well, I'm not actually going to type all that stuff in. So, yeah, yet again. It's a local instance, guys. You can see the password, not really. But okay, so here's a good example. So you see the Nginx logs. I guess I didn't actually hit the application because I haven't submitted anything. Okay, so here we go. We have an Nginx request right here, and then you see right underneath it, there you go. It's actually being handled by the API, and the API is spitting out a 400. So maybe Nginx is having trouble handling something, and your application is just spitting some odd stuff back, but you got a 200 from the application and a 500 from the reverse proxy. Well, all you see is a 500, so you start digging through your application code like, what the hell broke? You don't even know where the error is. Oh, there you go, problem solved. So that's Docker Compose. You can not, so this is running locally, but again, all I have to do to say, you know what, run this remotely, eval, Docker machine, and remote host, same command, works, guaranteed. Simple as that. So with that said, we'll continue on down this perilous track. So that was Docker Compose. Now we're going to talk about Docker Swarm. And this is kind of the coup de grace of all of it. So kind of putting this all together, we have the ability to make images very easily. You can layer them on top of one of another. If you do get started using Docker, I would highly recommend figure out how many levels you can parse like the base image out to. So for instance, maybe there's some base security software that every deployment across your environment requires, okay? But you also need dependencies on top of that. So maybe you have an image for the base software, and then you have an image that pulls from that image and then puts all the dependencies on top of it. And then you have another image which takes that and then puts code on top of it. Because as many different layers as you can segment it out, when you're deploying remotely, they only have to pull the stuff that they don't have access to, or that they don't have locally yet. So if they already have all of the base images and the only thing that they're changing is the source code, then pushing that out and pulling it down into the remote machines takes 10 seconds, as opposed to pulling the whole image, which is 1.5 gigabytes large, which makes this very much useless. This is the utility of Docker, of kind of like you can make it super, super, super fast. So we have the images, we can put them around. We know that we're talking to a Docker daemon. We're deploying we're basically telling Docker daemon to spin up processes and chroot into these file systems, all of these things. And this is all nice. This is all very cool. This is great. But you know what? I don't have a machine. Well, I mean, I do through DigitalOcean if you need it, but you don't have a machine that has 20 cores and like 64 gigabytes of RAM and all this stuff. So I need to have multiple physical hosts. How do I address that? And this is the coolest part across any of them. A bunch of the hosting providers have their own solutions to this problem. Google, for instance, has Kubernetes. There's also some, I forget who has it, it's called Mesos and all these things, but the idea is how do you actually deploy across a cloud? All this stuff. And Docker, as far as I'm concerned, has done the best job with this because So for instance, with Kubernetes, this is what Google runs internally, and unless you need to be squeezing every single CPU cycle out of every single CPU you own, Kubernetes is overkill. It's like using Final Cut Pro to make, like, I don't know, a presentation for your grandma. It does not apply to the vast majority of people that need to use it. Docker Swarm, on the other hand, is painfully easy. It hurts me how easy it is. I only said that because I didn't mean to say painfully. Let me come back over here to Docker Machine. So we see some timeouts here. What I'm going to do, so you saw before how I did eval, Docker Machine, env, default, and then all of a sudden I'm talking to a different Docker daemon. So what Docker Swarm does is it listens on a different port, by default TCP 3376. And so what I want to do, basically I have this thing here called Swarm Master, which is currently timing out. Let me do another ls and see how that works, to see if it's still timing out. It shouldn't be. I hope it's not. Demo gods are the worst. It's not timing out. Woo! So you'll see that we have some information down here, Swarm Master, and then you see it kind of has this column that says Swarm, and then it has in parentheses Master over to the right-hand side. So what you have to do with Swarm, very easy to deploy. Well, I mean, depends how much you like command line arguments. You have to add an additional command line argument to Docker Machine, and then it just works. So if you're opposed to that, this might be difficult, but otherwise I consider this pretty easy. And now that is designated as the master swarm node. And then you'll see I have a bunch of things like swarm node 21, 22, 23, 24. And in the swarm column, again, it's saying swarm master, but they don't have the master tag. So what does it actually do? So again, we have the Docker command line interface. We're talking to remote daemons. We have this API that we're talking to them over, right, an HTTP API. And everything just kind of works, okay? So what Docker Swarm does is it abstracts all of the nitty-gritty details of deploying across a cloud away from you. You don't have to deal with it anymore. All of your Docker commands continue to run just as well as they did previously. They have no idea that they're talking to a swarm daemon instead of a regular daemon. And the swarm daemon is just saying, oh yeah, I'm actually only one host with 30 cores, just whatever you need. And then it handles I'm going to put this container there and this container there. This goes back to the whole CPU shares and the memory allocations and stuff. You can say, well, this process needs at least one core, things of that nature. So Docker Swarm, when it's provisioning, like, oh, I'm going to put this container in these different places, it knows I already have one container that is taking over all of the cores of that machine. Let's not put another container on that host, things of that nature. So, but you don't have to configure that. It works out of the box without configuring it. So as your deployment gets more complicated, you have the ability to kind of like batten down the hatches and control where things are deployed at a finer granularity. So I'm going to now, so this, let's see, so people probably can't see that. So again, I'm evaling this Docker machine command, and here's the only difference. I say docker env swarm master, but then I also pass it this tac swarm parameter. And what that does is say, you know what, instead of 2376, you want to be talking to this endpoint on 3376, because that's where the swarm daemon is. Demo gods, you are assholes. And try it. Third time's a charm. All right, so I'm going to try to. I'm going to see if this is probably going to screw everything up by doing this.
Of course. Is there any way to make that default that it's just always using the swarm if you like worked in that sort of environment all the time?
Why would you want it to be a default?
Just if you worked in like the swarm, or if you worked like in the swarm environment like, all the time, or
The difference between you talking to the swarm daemon and then you talking to another daemon running locally is literally just this right here. That changes it. So
Yeah.
I don't know what the utility of having it immediately out of the gate. But you can name a particular machine as default, and that will be the default one that you talk to. But generally speaking, so in my experience with working with Docker, you kind of are switching who you're talking to all the time. Because basically I'll write code, get it running locally. Okay, that's cool. Push it to the registry, change who I'm talking to. I'm now talking to the swarm daemon. Tell the swarm daemon to pull the images down and then run them all. So it's common practice to be switching where you're talking to. So I don't know if there would be very much utility in doing that. But you can name something default that will be the one that if you're not you haven't specified who you want to talk to yet, that's what it will go for. So I wish this was working, even though it's not. I can tell you what would happen. Basically, when you use Docker, there's a command that Docker supplies. It's called Docker info. And Docker info reaches out to the daemon that's currently configured, says, hey, give me some information about yourself. And then it comes back and says, oh, I've got this many cores, I've got this much memory, I'm running these containers and all these things. When you connect to a swarm daemon, what's kind of cool is if I have 20 machines in swarm and they all have 2 cores each and 4 gigs of memory each, well, I connect to the swarm daemon and I say, hey, tell me about yourself. And it says, oh, I've got 40 cores. You have 40 cores, got all this memory. So it literally is virtualizing across all of these hosts, saying that I'm actually one logical host. So your code does not have to change between you deploying it locally and you deploying it across a cloud environment. And that is huge. Not only that, but your swarm can be across multiple hosting providers. So I can say, you know what, I'm going to have 5 nodes in AWS, 5 nodes in DigitalOcean. I'm going to have some in a colo over here. I'm going to have some there and some here. And as far as the swarm daemon is concerned, that's all one machine.